Hi guys, let's get this party started. I'm Ted. So this was a highly requested video for the cohort because some of the beginners were really struggling for how to use Python for quantitative finance, and I was suggesting a lot of reference material, but again it was not centralized for quantitative finance and it was taking a lot of time for people. So this I had a lot of videos already in the pipeline ready for posting in cohort, but I pushed this in the timeline very quick so that you guys can at least the beginners can start using Python for quantitative finance and start making their own models. Now what this notebook covers is basically almost everything that you should know, but again you have to do your due diligence and a bit of research on how you can better utilize Python for quantitative finance. Now this is not a generic tutorial. This is like every concept is specifically taught for markets, data, and money. Now, let's see. Learn just enough Python so you can vibe code the rest. Again, I truly believe you don't have to be a software engineer or a Python guru to make your own models. Means like you just need the conceptual knowledge, quantitative conceptual knowledge, and so that you can tell your AI, your Claude, Gemini, Chat GPT to code it, and it will code it very quick so that you can utilize it very properly, and this will save you 10x of times instead of black boxes. Now let's see the topics here, why it matters, mindset and setup. Before anything we create our hypothesis, like what we are trying to do, what we are trying to accomplish with this strategy, the strategy that we are making, what data do we need, how much data do we need, right? Now Python fundamentals that actually matters in finance: variables, loop, functions, right? Numpy, the backbone, fast maths on arrays of prices, returns, and weights. Data frames, Excel sheets, but pandas are Excel sheets on steroids. I mean, millions of rows. And when the data gets too big, you can always use Parquet. So I use Parquet when that I'm using lower time frame data for, let's say, 10 years of data, 20 years of data, right? But other than that, CSV files that are the Excel sheets with a single sheet are just fine. Now, data visualization, we use Matplotlib, Plotly, financial data acquisition, getting real data into Python, core quant concepts in code, returns, volatility, sharp drawdowns implemented. Again, implemented, I've already taught what they mean and how you can, let's say, perceive them for your own model, but this is implementation part. Back testing and strategy basics, to why code, and what to specifically understand, right? And now the library, the last part is library, cheat sheet, and roadmap, your reference guide going forward. Let's start with phase zero. Guys, you are not trying to be a software engineer, you're trying to become someone who can think quantitatively, prototype really fast using AI, read and verify data so that you know what the code written by your AI is doing, and debug intelligently. When AI generated code breaks, it will. You should be the one to fix it, right? What vibe coding means for quants: vibe coding is using AI to generate code while you guide the direction. It works beautifully if you understand what the code does, what the output should look like, and what the data should contain, the domain knowledge. Without these fundamentals, vibe coding becomes vibe praying to God, right? Now the 80-20 rule, the things that you should learn deeply, that is data types and structure, panda basics, some fiera ops and function writing, reading error messages, basic plotting, financial math concepts, that again financial math concepts we are covering in the cohort, and what you can vibe code freely: complex web scraping, advanced ML pipelines, dashboard, UI, API integration, database management, complex visualizations, and optimizations of algorithms. Now how to download your Python and install your Python: you can easily do it from anaconda.com. It's very beginner friendly. Or if you already have Python, you could always install these things: NumPy, Pandas, Matplotlib, Finance KP. What are these? These are the basically libraries which contain the pre-built code modules, so that you don't have to do. So I will tell you the difference between C++ and Python, why Python is so beginner friendly. So let's say you are trying to code a formula for standard deviation, right? And in Python, there will be a library which already knows, which has already pre-built coded the standard deviation formula. You just have to call the library and use the standard deviation function, and it will do the rest. Whereas in C++, you have to write the formulas entirely yourself. But it is used in low latency trading, right? Now Anaconda, it's very easy to download. If you don't know how to use Anaconda, just go to the YouTube and check how to download Python from Anaconda, right? It's very easy. Now phase 1, Python fundamentals that actually matter: variables and data. In quant finance, we are working in numbers, strings, booleans. Booleans is yes, no, true, false. Is the market open? Did we hit stop loss or not? None. Missing data, very common in financial data sets, even if you are using paid data sets, right? As you can see, 100 is a type int, that is integer. Decimal points are type float, that are floating values. AAPL, it's a string value. String values are alphabetic values. True, false, boolean, none is type, none type, right? Now again, I have ensured that the entire code that I'm writing for these, it's very heavily commented. What are comments? As you can see right here, these hashtags are the commented parts. It's not readed, it's not readable for your Python. It's for your own reference, like it's your own personal notes, so you know what the code is doing, right? And I've commented a lot of code lines so that you get a gist of it, right? Now basic arithmetic and PNL calculations, this is the code for that. Again, list, collection of data. Lists are order collection. In finance, a list of closing price, a list of tickers in your universe, a list of daily returns. Critical operations, indexing, slicing, appending. You don't have to have a deep knowledge about that. Just go to your AI and just get the basics of indexing, slicing, and appending done. Now let's continue with these are very easy, I mean very easy to understand. This is slicing, how slicing is done. This is indexing, the portfolio of tickers, week, how you can call the data, etc, etc. Append is basically add something to the list. Now this is how you can use to create list. You will use this everywhere. With this you can utilize filters, transform data. Now dictionaries. Dictionaries are value pairs. Dictionary maps keys to values. In finance, ticker is equal to price. Ticker has also weight in portfolio. Ticker also date also has OHLCV data. This is the most natural way to represent portfolio data. This is the code for that. Guys, if you're having difficulty with this basic, just let me know. Otherwise, you could always use this Jupyter notebook as a reference and use AI to help you explain little bit tiny nitbits of what you are missing, right? Now let's go on to conditional and loops. Every trading system is built on if then logic and iteration. If MA crosses the price on the upside, it's a buy. If drawdown is more than 10%, reduce position. Loop through each day in back test. Scan every ticker in your universe, right? These are the conditionals, simple signal. Now for loops, if this statement is true, we do this. Else if we do this, or else is something that we will do this. Now this is day-to-day simulation, how many years to double at 8%. Simple compounding logic, right? Now functions, reusable logic. Functions are the key to clean quant data. Every calculation you do more than once should be a function. Functions let you wipe code at a higher level. Instead of asking AI to calculate any returns and volatility, then Sharp ratio, you can say use my Sharp underscore ratio function. It will make it easier, right? These are some why we use def is define. You're defining that function. Once you define the function, it is always stored in your memory until you are restarting your kernel, right? Now these are the use case of the functions. Now error handling. The data is very messy. Financial data is notoriously dirty. Missing values, API failures, division by zero on flat days. You need to handle errors gratefully. The four most common types of financial data bugs: zero division error, type error, key error, and value error, as mentioned here. These are the defined functions and how you can solve them, how you can print them, how the warnings are displayed. You can see right here, right? Now, phase 2, NumPy, the backbone of quantitative Python. NumPy is numerical Python. It's a foundation that pandas SciPy, and ML libraries are built on. Why NumPy matters for quant? It's very fast, 10 to 100x faster than Python list for maths. Vectorization, apply operations on it at to entire arrays at once, no loops. Math built in basic mathematical functions. Mental model, 1 day, 2 day array operations work element wise. Now this is the code for that, guys. You can see right here the comments that I've added so that it's easy for you. Still, if you're having any doubts, just give me a DM, or you can always use your AI. Right now, the vectorized operations, the power of NumPy. No loops needed. Operation applied to every element simultaneously. Calculate the as you can see right here. Right, calculate daily returns in one line. No loop. Price is one. Call in all prices except the first one, and then prices colon -1, all prices except the last one. The daily returns will be calculated, logarithmic returns will be calculated. I've talked about why logarithmic returns, they are additive across time. Now, key statistical functions, you will use these daily standard deviation, annualize return, annualize volatility, minimum, maximum return, median, very common stuff. The fifth percentile, the first percentile, right? Portfolio math with NumPy is simulated daily return for three assets. Each row is 1 day, each column is one asset. These are the weights attached to it, and the portfolio returns very basic again, asset return shape. And now daily portfolio returns, covariance metrics, Monte Carlo simulation. It's a very important. I think I have talked about Monte Carlo. If I'm not, let me explain it. So Monte Carlo, it's like you have a 52 card deck, and you have, let's say, a hand of three aces, but you want to know how many times the three aces will be there. Or in, let's talk in financial terms, let's say you took your back test took 500 trades. So what Monte Carlo, very basic Monte Carlo will do is shuffle the trade data. So maybe it will shuffle the candle data, it will shuffle, let's say you took one win, two win, three win, then loss. It might do win, loss, win, win. So it will shuffle the data, right? Simulations. It could be 1,000 simulations, 25,000, and 100,000 simulations, right? Now, the phase three, pandas, your daily driver. Pandas is what you will use 80% of the time, but if you want to make it even more fast, you could always use polars. Pro tip. Now, what is pandas? Excel sheets on steroids. It's like SQL in Python, filter group join data. Now, key concept, series data frame index. Why pandas is better than Excel for quants? Handles millions of rows. Excel dies at 1 million. Reproducible analysis, built-in rolling windows, resampling, merging data time index, understanding business days. This is the data, this is the define function, this is the print, you can see right here. Now, adding calculated columns, you will do this constantly. Every time a loop or iteration is being done, the daily returns will be calculated, the intraday return as a volatility proxy, everything. These will be appended into the columns, right? But now rolling windows, this is very important. Rolling windows, I've talked about rolling windows. So basically, it helps you avoid overfitting. Rather than using the entire past data, you use 50 days, then 50 more days. So how can I explain it to you in layman terms? Let's say the warm up of rolling window is done from 1 to 50 day, right? And the value is 10. Now the data, the model will know that the value is 10, and it will trade accordingly. Now 1 day has passed, the data is from day 2 to till day 51, and now the new value is, let's say, 10.2. Now this is the example of rolling window. It will take the most recent 50-day data and act accordingly, right? Create a longer data set for meaningful rolling calculations. Now let's continue. This is very basic formulas, very basic coding. Return statistics, resampling of data, monthly returns. Now, phase for data visualizations. A lot of you guys are always bugging me how you are creating these visuals. Matplotlib, Plotly, very easy, simple, right? Now, you can't trade what you can't see. Visualization is how you spot bugs in your data. It could be a phantom crash. A phantom crash is like your equity was going slowly up and it crashed. That is a phantom crash. Now you could spot bugs, communicate results to yourself, to your model and others, develop intuition about market behavior. It's very important to have intuition in quantitative finance or trading in general. Now the essential plots for quant: line plot, histogram, heat map, drawdown chart, multi-panel. I will show you the example. So this is the line graph. As you can see, 20-day SMA, 50-day SMA has been produced. Now this is the histogram, again line chart. As you can see right here, the code for that. Correlation heat map, very basic amongst Apple, Google, Microsoft, Tesla, JP Morgan, and gold as a ETF commodity, right? Let's see. Equity curve drawdown, very basic. You can see it's like equity, the peak is there, right? The peak is right here. The peak is here till this period, then the peak was broken and the equity went up. This is the underwater, it's called the underwater chart as well. Maximum drawdown was 21.4%. Now the phase 5, how you can get data. Very free data sources are Yahoo Finance, CCXT, Pandas data reader. You also have paid data sources: Polygon, Quandl, Bloomberg. Bloomberg is very expensive, ignore it for now. You can use Data Bento, you can use Took, STOOQ, and you have Alpha Vantage as well. And any of your if you are using CFDs, you can get free data from your CFD broker. It could be IC Markets, Vantage. It's very easy to get data, trust me. If you're having trouble getting data, just let me know, for free. Now, yeah, again, level 1 data is fairly easy to get. If you're trying to go to microstructure, level 2, level 3 data, it's definitely paid. This is OHLCV. What is OHLCV? Open, high, low, close, volume, right? Now, download multiple tickers, how you can download using Yahoo Finance. This is the data, this is the analyzed statistics. Now, visualizing the real data, normalized price. So, see, each of the stock has different stock prices, different returns. So what we do is we normalize the price on a scale of 100, taking the base as 100. As you can see, Tesla was the highest returning and it was most volatile right here, whereas the other follows the same, right? Now, the phase 6, core quant finance concept in code. What you will implement every day, what you will have to check, what you will have to debug: returns, volatility, Sharpe ratio, risk adjusted metrics, maximum drawdown, value at risk, beta, and correlation. You need to know at least these specific concepts in depth so that you know what your AI is doing, how it is vibe coding. This is a sample code that I've uploaded for you. Now, full performance report using the toolkit that was already defined above. This is the define max drawdown. You can just hide it. You can make it bigger, up to you. Now, this is the strategy performance report. Every model of yours should have this report so that you could compare how good it is, is it improving, and all that, right? Now, phase 7, backtesting and strategy basics. A backtest answer: if I had followed this strategy historically, would have I made money? Would have I lost money? What's the best money I could have made? What's the max drawdown that I could have? Now, backtesting workflow is get data, generate signal, calculate position returns, analyze performance. Very simple. Again, I've talked about this. Quantitative backtesting is full of traps: overfitting, look ahead bias, survivorship bias, and transaction costs can make a terrible strategy look amazing. You can check the common quant mistakes module to go deeper, right? SMA crossover basket, negative returns, 46% time in market. Again, I've told you before, right? It's SMAs, EMAs just don't work anymore. Visualize the backtest. Now, this is the example for multi-panel dashboard. I use, I think, 7 to 8 graphs in my multi-panel so that I could have a detailed visual, so that I could understand what the returns are, how the strategy is performing. This is the SMA, EMA, right? As you can see, it was unable to even beat buy and hold on, I think it's SPY. The data was already downloaded above. Yeah. Now, let's add transaction cost. This is what differentiates a real backtest from an artificial, especially for high frequency trading. When you are doing, let's say, 10 trades a day, if you're not computing for transaction costs, your returns are completely artificial. You might be making, let's say, 1000% in a year, whereas in the reality, you might not even be making 10% in the year, right? Now, what to vibe code and what to understand deeply, concepts that I'm teaching in for quantitative finance, must know deeply, right? So that you know what they are doing. The financial mathematics that you should know: simple versus logarithmic returns, compounding, volatility, standard deviation, Sharpe ratio, drawdown, correlation is not equal to causation, survivorship bias, look ahead bias, data handling. All these skills you need to have pandas, data frame operations, handling NAN, missing data, data time indexing, reading error messages, very important. You should know how to how to read the error so that you know what you're trying to do. These I think I have already covered. Cherry picking dates, starting. So yeah, I know some of the quants on social media, what they will do is to create an artificial backtest. Let's say they will start their backtest from the mid of 2020, so that the crash has already happened and now they get to buy everything for cheap, and they will show extremely good returns, right? That's now not how you trade. You have to include different market regimes: sideways markets, bearish markets, bullish markets. That's why I always say that you should take more than 5 year data, because the past 5 years have been extremely bullish and you need to model for bearish and sideways markets. Now, what is safe to vibe code? Web scraping, API calls, complex visualization, database setup and query, dashboard building, file, CSV, Excel file generation, regex patterns, and ML pipeline code, unit test, scaffolding. Now, the golden rule: you have to understand the logic and you can always vibe code the implementation. If you can't explain what the code should do before seeing the output, you should not be vibe coding it. AI writes the code, you write the specification. That's the deal. Very easy. Example prompts are here, the results of the example prompt, the quality of vibe coded output, your domain knowledge. So the conceptual knowledge you have, the better quality result from vibe coding you will have. Your job is become the expert who has the conceptual knowledge and who can write the specification. The AI's job is write the code that implements the specification, right? Now the phase 9, the library, cheat sheets and learning roadmap, how you can, learn from A to Z. This is just the basics, right? Essential libraries are right here. These are the libraries, what they are used for: array, math, random number, linear algebra, everything with tabular data, plotting, market data, frequently used. You will learn soon definitely in machine learning, because these are mostly used in machine learning. Specialized, learn when needed: back trader, quant stats. Trust me, you don't use it often. What you use in these are Arch, TALib, CCXT, Streamlit, Plotly. These you will use. So for all of you degenerates or my fellow comrades who were asking, we need a learning roadmap for this. This is the roadmap: the foundation, the intermediate quant skills that you should have, and the advance. The advance will definitely take you some time, but this is what you should follow for Python. Now, this is your quick reference: Pandas cheat sheet, NumPy cheat sheet code, backtest performance example, and congratulations, guys! You have the Python foundation for quantitative finance. You could go and get any stupid certificate, it's not going to help, from Coursera or whatever. What you should do is actually follow this roadmap and you will be really good at quantitative finance and Python. Now, the next step is rerun all the plots with real data, explore, start vibe coding, but validate. Again, if you're a beginner, start learning with Python. That's the most basic part, with some financial mathematical knowledge. And then you can move to the intermediate section of the cohort. Guys, that will be all for today. I mean, thank you so much for being here. It's been a great journey till now. I hope I'm adding value to you. I'm always open for constructive criticism and inputs on how I can better to your needs. Thank you so much. Ted out. Bye bye, guys.